Hi, everybody. This is Mr. Ty, and welcome to podcast 1.1. We're going to name, describe, give the location of the three subatomic particles in the boron quantum models. Describe the differences of subatomic particles between elements, ions, and isotopes. Three different things. Give a neutral charge isotope, write the name and symbol, determine the number of protons, neutrons, and electrons. And then we also have the average mass. We need a calculator. So bust that out. You need the periodic table you got in class today, and let's rock. All right. Now, this is the bad part. You guys have to write down pretty much everything that I write down in most of what I say. So write down, whoops. Oh, man, this is jumping around on me. All of these, okay? So you want to determine the identity of an atom. So protons determine your identity, okay? So if I have 3 protons, I'm always lithium. If I have 1 proton, I'm always hydrogen. So if I have 3 protons and I have 3 electrons, or I have 5 electrons, or I have 7 electrons, or I have 99 electrons, I'm always going to be lithium. Okay. If I have 1 proton, no matter how many, now what if I have 1 neutron, or I have 2 neutrons, or I have 100 neutrons? In all those cases, protons determine the identity. Protons are positive. Protons have a mass of 1 atomic mass unit. It's kind of a cheesy made-up unit of mass, but it's 1. Protons are in the nucleus, and protons help determine if an atom is radioactive or not. And then if 2 particles with the same number of protons are isotopes. So we'll see below. So 3 protons, 3 protons, 3 protons. These are isotopes of each other because they have different masses. Okay, so you should write down 2 particles with the same number of protons are isotopes. Now, from what I just said, you should also write down same number of protons and different number of neutrons. So I won't always write down the stuff, but you are responsible for what I say as well. Protons don't change when ions form. Electrons change when ions form. So ions change to make it +1 or -73 or something like that. Electrons determine the charge. So you might have hit pause and go back a little bit to write down those things. And the chemical reactivity of particles. Electrons are negative. Electrons are in energy levels, not rings. Rings are wrong, okay? So this helps us with some things, but this is not the best representation. That helps us some, but it doesn't help exactly, okay? So they're in energy levels in the Bohr model. They're in clouds in the quantum mechanical model. This is the correct one. This is correct. This one is useful, but it's not correct. Electrons have no effect on radioactivity. Their mass is negligible, which means it's so small it doesn't matter. So if you think of Steve talks in class all the time. When Steve talks, no one really pays attention to what Steve says. It's not that important, but he does talk. It's just not important, so it's negligible. Okay, now you put so there, whatever. 2 particles with the same number of electrons might be different things. So neon, an element on the periodic table, and F minus both have 10 electrons, but they're different things. If you're a neutral atom and you become -1, you gain an electron. I usually call electrons gain a, and I sneak in the word negative, and I emphasize that electrons are negative all the time. -2 is gain 2 negative electrons. To be +1, you lose an electron. To be +2, you lose 2 electrons. Sox fans, I'm positive you're a loser. Although in 2 years from now, heck of a team. Neutrons determine the mass and nuclear stability of an atom. They're neutral, meaning without a charge. Their charge is 0. They are in the nucleus, in the quantum mechanical model, and in the Bohr model. Isotopes have the same number of protons but different number of neutrons. Again, that definition of this is the definition of an isotope. That is the definition of an isotope. Neutrons do not affect ion formation. So that means neutrons do not affect ion formation, means do not affect the charge. Okay. The mass of a neutron is 1 atomic mass. Isotopic notation. How many protons? Well, how many protons? That is the bottom number. Okay. This has 1. This has 92. This has 22. Okay. How many neutrons? Well, neutrons is mass minus protons. This top number is the mass. What's the mass of hydrogen here? 3. What's the mass of uranium here? 235. What's the mass of titanium here? 48. Okay. Now you should write down these examples. And you should write down and label them mass and label them protons. Okay? So neutrons are mass minus protons. So for this one, neutrons equals 3 minus 1, 2. For this one, neutrons equals, so remember, if it's mass minus protons, it's neutrons. 235 minus 92. It's the first day of summer. I'm being lazy. I'm busting out my calculator. A little bit of shame in that, but not much. 143. Neutrons equals 48 minus 22. I'm feeling smarter now. Summer's over. 26. Okay. This is isotopic notation. How many electrons? Electrons equal protons. Hey, my first person in the room. Equals protons unless there's a charge. And we'll do the charges a little more later. Okay. So if there's 1 proton, electrons equals 1. Electrons equals 92. Electrons equals 20. Standard notation. How many protons? Well, this comes from the name. So you're going to have to look at your periodic table. So get out your periodic tables. And if you look at the periodic table, you'll see that the whole number is the number of protons. So carbon, the number of protons is 6 because the periodic table says 6. Rhodium's a little harder to find. It's in the middle. Rhodium symbol is RH, and that is number 45. Calcium is on the left-hand side, and it's in the 4th row, which is 20. Okay. Then we have neutrons. Neutrons are still going to equal mass minus protons. So this one right here, this number right here is the mass. This number right here is the mass. This number right here is the mass. So mass minus protons, so neutrons, ooh, get back here. Neutrons, come on, equals 14 minus 6 is 8. Neutrons, sorry about this. Neutrons equals 102, neutrons equals 102 minus 45. And that's not quite 60, it's going to be, 45. It's going to be 57. And this one's going to be neutrons equals 41 minus 20 equals 21. Okay. And that's the number of neutrons. How many electrons? And again, electrons equals protons unless there's a charge. And these don't have charge. You'd see a charge where it would say +1, +2. Okay. Ions have a charge. What would be the isotopic notation of sulfur-33 with a -2 charge? Okay, so sulfur. Get out your periodic table again. This bottom number is the number of protons. That's the whole number. Oh, man. So this is 16. This, remember, is the mass. It goes on top. Oops. This is the mass. It goes on top. Charge of -2, I put it right there. Okay. So if you're a negative ion, it ends in I. It ends in E. What would be the isotopic notation for strontium-88 with a +2 charge? So strontium symbol is Sr. And I look in the periodic table to find out what the bottom number is. And strontium is in the 5th row. It's the second one over there. It's going to be 38. And if it's strontium-88, that's the mass. So my top number is 88. It has a +2 charge. Give the isotopic notation for 2 different isotopes of aluminum. dash 27. Uh-oh. Isotopic notation for two different isotopes of aluminum 27. So I'm going to have aluminum still. Aluminum always has 13 down here. It needs a different mass. Aluminum 28. It's different mass. Another one would be aluminum. Number of protons is the same. 29. So see how the mass will change with different isotopes? I'll get back to it. Okay. Give two different ions for bromine-77. Bromine 77. 77 goes on top. Ions have different charges. So it's going to be 79. And bromine, if I just put charges on it. So stop it, man. -1. 77. Oops, I think I put the wrong number. 35. 77, 35. Now bromine needs another charge, a different charge. Okay. So the last thing we're going to do is, oops, I got this flip around. Oh no. Oh, looks like we're going to break this into two parts. So, oops, sorry. That was fun. It's because the big bleep, 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 because they took out, oh, just cancel it. They took out one of my electrical outlets, so I can't plug in. So, hey, we're still recording. Let's see if I can pull that one back up. Oh, there's no way I'll be able to pull that one back up. We'll give it a shot. But you know what? This is a good place to stop. So we will do average atomic mass and roll that into the next one. So we will, is it going to work? It's going to work. So that's going to just keep on trying. So what we're going to do is we'll shorten it a bit, is I'll show you how to do average atomic mass. Whee! Sorry about that almost ending joy. You can minimize that. Okay, so the average atomic mass is something. So the formula to find an average atomic mass is percentage 1 times mass 1 plus percentage 2 times mass 2. And then I'm going to put dot, dot, dot. You can repeat that equals average mass. And that's pretty much it. So if I have percentages, okay, oops. Percentages are really decimals. So do you see how this is a relative abundance? This is 78.7%, but we're going to use the decimal form of it. So all I'm going to do is percentage 1, 0.7871, mass 1, 23, get back here, 23, get back here, 23.985, plus percentage 2, 0.1013, times mass 2, get back here. Yeah, I'm going to try and write this all over again. Okay, so I'm going to start again. Percentage 1, 0.7870 times 23.985 plus 0.1013 times 24.986 plus 0.1117 times 25.983. So if you see equals, you see I've got abundances, which are percentages, times masses. That's as hard as I can do. Usually they'll be listed as percentages. Then I get out my calculator for reals. 0.787 times 23.985. These are my masses. Equals. Plus quantity. 0.1013 times 24.986. Close quantity. Plus quantity. 0.1117 times 25.983. Close quantity equals. And the answer that I get is 24.31. And that's going to be A and U, or U, I guess is what they have here. And this should make sense. Most of these things weigh 23.985, so my average should be closer to 24.31. Notice we did not, not add and divide by 3. And the reason for that is because there's different abundances. Almost all the time, if you get a 78.7%, but just once, almost all the time we got 23.985, but once you get those two grades, your grade shouldn't be that close to it. Okay? So, since my computer is being a big poop, and we've got time to review this in class, we can look at our summary, know how protons, neutrons, and electrons change, and ions, isotopes, and the Bohr quantum model. Write the isotopic notations, and do average atomic mass, and we are done. Toodles, thanks for listening. I appreciate it. Bye.